Have you ever gazed up at the night sky and wondered about the mysteries of space? The vastness of the cosmos, the twinkling stars, and the distant galaxies all spark our curiosity. One question that often pops up is, why is gravity weaker in space? It's a common misconception that space is devoid of gravity. It's a question that has puzzled humans for centuries. From the early astronomers who charted the stars to modern scientists who send probes to distant planets, the nature of gravity has always been a topic of fascination. After all, we see astronauts floating effortlessly in space stations, seemingly free from gravity's pull. So, what's going on? The truth is, gravity is still at work, even in space. The sensation of weightlessness experienced by astronauts is due to the fact that they are in a state of continuous freefall around the Earth. Is there something different about gravity in the vast expanse of space? Not really. Gravity exists everywhere in the universe. However, its strength diminishes with distance. The further you are from a massive object, like Earth, the weaker the gravitational pull. This is why astronauts in orbit around Earth experience microgravity, a condition where the force of gravity is much weaker than on the planet's surface. So, while it may seem like gravity is weaker in space, it's actually just a matter of perspective and distance. The universe is a complex and wondrous place, and understanding the forces at play helps us appreciate the beauty and intricacy of the cosmos even more. To understand why gravity seems weaker in space, let's first understand how it works here on Earth. Gravity is a force that attracts any two objects with mass towards each other. The more massive an object, the stronger its gravitational pull. The Earth is very massive, so it has a strong gravitational pull on us. That's why we stay grounded and objects fall to the ground when dropped. Here's the key difference between gravity on Earth and in space distance. Gravity's strength weakens as objects get farther apart. Imagine holding a magnet close to a metal object. The magnetic force is strong. Now move the magnet further away. The force weakens. Gravity behaves similarly. As we venture further from Earth's surface, its gravitational pull on us decreases. Section 4. Floating astronauts and orbiting space stations. The effects of this weakening gravity are clearly visible in space. Astronauts aboard the International Space Station, for example, appear to float effortlessly. This is because they are far enough from Earth that its gravitational pull is significantly weaker. However, it's important to remember that gravity is still present. It's what keeps the space station in orbit around Earth. Section 5. Gravity's long reach. It never truly disappears. It's crucial to understand that gravity never truly disappears, no matter how far apart objects are. This fundamental force of nature is always present, always exerting its influence, even if we can't always feel it directly. It just gets weaker with distance. Think about it. The Moon, despite being quite far from Earth, is still held in orbit by Earth's gravity. This invisible force keeps the Moon in its steady path around our planet, creating the tides and influencing the natural rhythms of life on Earth. The same principle applies to other celestial bodies. Even the planets in our solar system, though millions of miles apart, are bound together by the sun's gravitational pull. This force keeps them in their orbits, maintaining the delicate balance of our cosmic neighborhood. Even distant galaxies exert a gravitational pull on each other. Gravity's reach is infinite, extending across the vast expanses of space. This means that every object in the universe, no matter how far away, is connected by this force. Even if its strength diminishes, gravity's influence never truly vanishes. It is a constant, unyielding presence that shapes the structure and behavior of the cosmos. From the smallest particles to the largest galaxies, gravity is the thread that weaves the fabric of the universe together. Section 6. Solving the cosmic puzzle. Distance is key. So why does gravity seem weaker in space? This question has puzzled scientists and enthusiasts alike for centuries. The answer lies in the concept of distance. In the vast expanse of space, distances between objects are immense. Gravity weakens as objects move farther apart. This weakening effect is due to the inverse square law, which states that the force of gravity decreases with the square of the distance between two objects. While astronauts may appear to float in space, they are still under the influence of gravity. They are in a state of free fall, orbiting Earth, which creates the sensation of weightlessness. It's just that the pull of gravity from Earth is much weaker at that distance. The farther you are from the source of gravity, the less you feel its effects. Gravity is a fundamental force in the universe, and its influence extends far beyond our planet, connecting us to the vast cosmic web. This cosmic web is a large-scale structure of the universe consisting of galaxies, gas, and dark matter, all held together by gravity. Understanding the role of distance in the weakening of gravity helps us comprehend the structure and behavior of the universe. It explains why galaxies can exist so far apart yet still be connected through the gravitational pull. Gravitational waves, ripples in spacetime caused by massive objects like black holes, also travel vast distances, though they weaken as they spread out. Even black holes, with their immense gravitational pull, have a limited range of influence. The farther you are from a black hole, the less you feel its gravitational force. This understanding of gravity and distance is crucial for space exploration and the study of astrophysics. It helps scientists plan missions, understand the behavior of celestial bodies, and unlock the mysteries of the cosmos. So as we continue to explore the universe, remember that distance is key. It shapes the way gravity influences everything, from the smallest particles to the largest galaxies weaving the intricate tapestry of the cosmos.